Welcome. Previous class I was discussing about that reducing reagents, that is Grignard reagents. With that I solved some examples, but some examples I did the mistakes that I want to rectify. So please rectify that. I am sorry for that mistakes. Okay, so this example I did the mistakes. What that whenever I see the solutions on that time, what that in the answer there is a stereochemistry is mentioned. So if in any compound, if stereochemistry is mentioned, then always try to make that compounds where actually it is actually exists. Let's say this is a cyclohexane. So this cyclohexanes, we write like this, but it is actually exist in the chair form. So first we will convert it into the chair form. Okay. So chair form we convert that. After that we do the numbering 1, 2, 3 for um, make it easier. So here one we have let's say this carbonyl groups, and this is 1 and 2 and 3. So at 3 we have the phenyl groups. So if phenyl groups or any bulky groups are there, whether it may be that Norwegian systems or in the chair form, if that bulky groups is there, they always make them in a equatorial positions. If the stereochemistry is not mentioned, if stereochemistry is mentioned, let's say if stereochemistry of this pH is, let's say, like this, and stereochemistry is mentioned like this pH, then on that times we have to do it in the above form. It means that this at 3 we have to make it the axial form. But here since chemistry is not mentioned, so to avoid 1,3 diaxial interactions, I will do that equatorial form. Okay, so equatorial form is down, so we will do that like this. pH. But if stereochemistry is mentioned like this, then there is no options that we have to do in a axial form. Okay. So if stereochemistry is not mentioned, then try to do that bulky groups in a equatorial forms to avoid that 1,3 diaxial interactions. But so here that stereochemistry is not mentioned for pH, so I simply do in a equatorial form. Now I have these groups, and that at 2 3, so at that 2 this is 3, and 2 3 what we have, that double bond is there. So make that double bonds. Okay, so this is actual exist, this is actual exist in this form. Now we have that reagents, that is Me, MgCl and CuCl. So in previous class I also says that whenever with a magnesium, if that any copper is given with copper halides, then what will happen, there will be a trans means that the exchange will happen, means that this copper will exchange with this magnesium. So this is actually what you will get, that MeCuCl. Okay, so this magnesium and copper, they will exchange. It means that now we have that copper, and the size of copper is very very big, and if it is a big, then on that case what we see, that will become a soft reagent. So these overall reagents become the soft reagents. Okay, now if that CuCl is not mentioned, on that case it is a hard reagent. But if copper with any halogen is given, then on that case this magnesium is replaced by this copper, and this total become a soft reagents. Unlike that, if it is not mentioned, then that is a hard reagent. Okay, now we see that this CO is hard and this is a soft. Okay, so this is a soft, so soft has a good interaction. So this methyl, that is Me minus or CH3 minus, this will attack to the these positions, means 1 for additions will occur. So how will do that? This is 1, 2 and 3, and this is 4. So 1 for additions or conjugate additions or Michael additions will happen. It means that what it will happen like this, and this will this magnesium will attack here. Since pH is already in that axial form, so this has to do that. So pH is already in the equatorial positions, so this Me will attack, means there is no options, because in any groups there is either axial and equatorial. Okay, now equatorial is already filled, so this has to attack to that axial positions. Here we will not check that 1,3 diagonal interactions. Reason is that here there is no only options, because in one position there is only so in one atoms there is only two-way attack. One is axial, another is equatorial. Now that equatorial is already filled, it means that it has left only one way, that is it has to attack that axial positions. So it will be attack axial positions. Here we will have that CH3. Although 1,3 diaxial interactions has happened here, but there is no options. So it has to do that axial attack. So this is pH. So if it attack, then it will shift it to here, and this is going to be like this. It means that we will get like this, O minus. Okay. Now what will happen? Now we have this another times what they given, that another reagent they have given, that is this group. Okay, so now what will happen, that either it will attack or it will comes, then from this position it will attack. See that here this O will attack, then OC bond will pop. Now if it will comes to here, now it will attack, then CC bond will pop, and we know that CC bond is more stable than OC bond. So here it will not attack, it will comes to like this, and it will comes, and from here it will attack to this. Okay, reason is that CC bond is stronger than OC bond. So it will be like this. Sorry. Okay, so now what will happen, that this double bond will comes here, and this shifted to here, and this here, now it will attack to this one. So since this is also a bulky groups, and here that stereochemistry is not mentioned, so always prepare that in bulky groups, then axial attack will sorry, equatorial attack will happen to prevent that 1,3 diaxial interaction. So it will be like this. Sorry, here Cl was there. Okay, so it will attack to this, and this shifted to here, and this is removed. So it will going to becomes like this and this. Okay, so this is going to be the equatorial. So because bulky groups always prepare that is to attack in a equatorial positions to prevent that 1,3 diaxial interactions. And here we have that CH3, and here we have that pH. Okay, so this is that final answers for these questions. Now we will not get in the options this one. So this one again we have to convert into that original questions form. Okay, now we will convert into the original form. So 1, 2, 3, 4, 5 and 6. So I will convert into that original form. So I can do here. So at 1 double bond is there. Okay, at 2 this group is there, and this is the above, because this is the down, this is above. So that how we will do right here like this. Okay, 1, 2. Now at 3 we have that CH3 the above, so CH3 is above, so right here, and pH is in the down, so pH is in the downs. Okay, and that this is that 1, 2 and 3, so only 3 is that. Then this is the final answers for this questions. Okay, so for that questions, this is the final product. So we will get this in the options. Okay, we will not get this one in the options, this one we will get in the options, and this is the correct answers for these questions. Okay, so look that in the solutions whether stereochemistry is mentioned or not. If stereochemistry is mentioned, then on that case convert it into that which actually that compound exists. Okay, after that we will do that this where it will attack axial. So always 1,3 diaxial interactions they want to prevent, but if there is no options, then they has to do that 1,3 diaxial interactions. Okay, and that to avoid 1,3 diaxial interactions, what they used to do, that they used to attack simply the equatorial attack. Okay, so this is all about of this problems. Now we will look to the next options, next examples. So this one also I did mistakes in that previous class. Okay, so now what we see here, in this case that pH mgbr, so this is highly polar because that pH and mgbr, this is positive charge and this is negative charge. So due to polar, this is a very reactive, and we seen that this is a hard reagents. The Grignard reagent is a hard reagent and this is also hard, so this will attack to this one, two direct additions will happen and this will shift it to like this. So what we will get here, so stereochemistry is not mentioned, so simply do like this. Here you get O minus and here we have that pH. Okay, now what happened that had TSOH is given. Okay, so this TSOH, that previously I did something this and I remove it, that is wrong, totally wrong. Okay, so that I did like that, sorry for that. So what actually this happened, that TSO and this is H. Okay, so this will what happened, that this will attack to this as, sorry, this will attack to these protons and this is going to release like this. So it will going to be that this way. Okay, this we get here that OH and here we will get that pH. Okay. Now what will happen, that you see that this is this carbon center, here OH is there again in the solutions, TSOH is there. Okay, so another that this give that H plus, so here lone pair is there. So what we will do, that here dehydration chances is possible. Why? Because that if this OH is upset accepting one H, if it is removed, then here that 3-degree carbocation is forming, and we know that 3-degree carbocation is very stable. One thing, this is 3-degree with that phenyl is there where it is conjugations is also happen. It means that this carbocation is highly stable. So what it will do, that it will attack to this H plus and what we will get here. So look that if there is a chances of forming stable carbocations, then that will fall. That's why that intermediate is very important. With reagent, intermediate also very important. Okay, so this is going to be that O, here is H and here is H. Now it become a positive charge. So this water will be removed because this become a good leaving groups. After that, what will happen here? And this is going to be that pH, and here we have that positive charge. Okay, now what will happen, that here to this is a highly carbocation, so here dehydrations will happen. It means that this hydrogen will remove here. Okay, and here we will get that this group pH. So this is that final product for these questions. Okay, so this hydrogen will be removed for that to stabilize the carbocations, and this is going to be that final answers. So here what happened, that dehydrations will occur. Okay, so look that if any stable carbocation is forming or not. If stable carbocation is forming, on that case that leaving group will leave and that will happen, that the water will remove. That means that dehydrations will occur. This is actually what happened, that this remove, after that here H is there, so that H will remove and form this group. Okay, that I did mistakes in the previous class. I never like I not observed that this stable carbocations, I simply did like this, so that is a very bad answers I did, so I am sorry for that. So this is actually happened, that this will go and this will be the final answers for these questions. Now moving to the next questions. So in this case again, so here what happened, that MEMGBr, so 82, this is the solvent. So now what will happen here, that type of things will not happen. See here, this is again this is a hard reagent, because if carbon lithium or carbon any halogen is there, on that case only that become a soft reagent, but now this is a hard reagent, so it will do that one to direct additions. It means that it will direct add to this. So what you will get here, here we become O minus and here we become that CH3. Okay, and here that same things will be there, and here we have that methyl groups. Now what happened, that hydrolysis they did, it means that this is going to give that H plus and it will attack to it. So what you will get here, this is going to be that OH and this is going to be that CH3 and this is that methyls and this is that product. So now what will happen here, again we see that here if this water will remove with this H plus, if except here, because here lone pair is there, then again a stable carbocation will pop. So if it will remove, then again a stable carbocation will pop. So what happened that this H3O plus is there, so this is going to give H plus. So this lone pair again attack this H plus, and what it will becomes? Okay, so this is going to become that OH2 plus, and here CH3 is there, because after leaving this water we have this carbocation and that is a 3 degree stable carbocation will pop. So that always, if the carbocation is 3 degree, then that always it will pop. Okay, so this is going to like this, and here is methyl groups. Okay, so now what will happen that this water will release here, and here we have that methyl groups, this, and here that water will release. So this will be the CH3 and here we have that positive charge. Here we have that positive charge. Now what will happen that here that water is here, we can remove H here. Here that H cannot remove from here. H will release from here. Reason is that if it is released from here, because if it is released from this sides, then here also H is present. Okay, now see that both the options. So whenever if you confuse, then do both, and where it is stable, that we have to look. Okay, so now I will do both. Here suppose if I release this H to stable this carbohydrates, then what will happen here, this, and here we have that CH3 and here we have that, and here we have that methyl, and here this is there. Okay, this is the one. Now if this will release, then if this will release, then what will happen on that case? On that case, what will happen? This will become like this, and this is the CH3, and here another bond is there. So this is not possible because double bond are near, so this will not happen. So this will be the final product for these questions. It means that if a stable carbocation is any chance to pop, then that will pop by doing the dehydrations. Okay, so that one I not able to did in the previous class, I did mistakes. Okay, so that you rectify that one. So here the water will be released. Now moving to the next questions here. So next questions, in this case, what that here that copper is there. Okay, so with magnesium copper is given, then there will be that replacement of this magnesium with copper will happen, and whenever this copper will come, this become that soft reagents, and if it is soft reagent, then this is the hard reagent, so it will not attack here, and this is the soft, so it will attack to this. Here we will getting that Me minus, and this will attack to here, it will not attack to here. Okay, it will attack to here. It means that what you will get, so it will attack to this, then here one methyl is there already and another methyl will comes. Okay, and now this shifted to here and this will become O minus, and here nothing is there. After that hydrolysis they did, it means that water will comes here. So see that here water will comes here, then what will happen that OH bond will forms. Another case that if it will comes here and it will attack, then CH bonds will happen. So now that OH bond is stable or CH bond is stable. So you see that here difference is electron electronegativity difference is very high. So that OH it will not form here, it will form that here, because chances of CH is more stable. So it will form actually. So this will return back here. Okay, and now what will happen that here will be that H will comes, and this and this. This is the final answers for this questions, for this type of questions. Okay. Okay, so for these questions, this is the final answers. Okay, so this I did mistakes in the previous class, please rectify it. Now one more things I forgot to mention about of that Grignard reagents. That Grignard reagents, what type of solvents you use, or you can say that, see, this is very important that for Grignard reagent we has to be very careful that whenever you are using that Grignard reagents, we have to be very careful that the solvents is that should be used in anhydrous conditions. Anhydrous means that without water. Okay, the solvent should be that that should not be a polar solvent. Okay, and that solvent and you are using that at that conditions where the water it should not be there, means that this Grignard reagent is very sensitive to that moisture. So that Grignard reagent is always used in non-polar solvents, like THF we can use, or we can use that ethers like diethyl ether. Okay, so the solvents should be always that non-polar solvents like THF ethers or diethyl ethers. This type of solvents we use, and that condition should be anhydrous. Anhydrous means that water free conditions, because that if in that because this Grignard reagent is very sensitive to that moisture, it means that if any water will comes to this Grignard reagent, then it will directly react with that water itself, and it will make some unwanted products that we not needed. So that will happen. So to avoid this type of unwanted reactions, what we do that we use that Grignard reagents in a polar, in non-polar solvents, and in a anhydrous conditions where water should not be present. That's why you see that whenever Grignard reagent, on the time it written as the dry ethers, or that ET2 or diethyl ethers or THF also used. Okay, so these are the solvents we need for the Grignard reagent, and that should be in the anhydrous conditions, means that water should not be there in that solutions. Also, what we say that that the solvent should not have that any acidic protons should not be there. We see that if acidic proton is there, then this Grignard reagent is a strong base, so that will directly attack to that acidic protons and it will do that reactions. Okay, so that solvent should not have that acidic property, means that alcohol should not be there. Alcohol as solvent should never be used. Should never be used, because it has that acidic protons, and this Grignard reagent is a strong base, so it will attack to that acidic proton and it will do some reactions. Means which we use as a solvent, that solvent itself react with that reagents. and make some other reactions. As a result, what you see that you will not get the expected product. Okay, so that's why that whenever you are using that Grignard, be careful about of these things. That alcohol should not be used, or any solvent if it has acidic proton, then we should not use that as a solvents. And that should be always in anhydrous condition, means water should not be there. And that prepared solvents, like we can use that THF or ether or diether ethos, this type of solvents we will use whenever you are using that Grignard reagents. Okay, another that things is that reactions of Grignard reagents, this one also I left in the previous class, that reactions of Grignard reagents, like if we have that carbon dioxide with carbon dioxide. So if you have that carbon dioxide, let's say you have that Grignard reagent, let's say we have this Grignard reagent, MgBr, let's say we have this Grignard reagent, and we have this carbon dioxide, and let's say we have that hydrolysis. Then what will happen? This carbon dioxide is actually existing. Okay, so what will do that? This actually what it is actually exist is that this is very polar, and it will what that this is exist as minus, and this MgBr this is exist as positive, and this will attack to this groups. Okay, so what it will becomes? Okay, and this become that carbon. Okay, and one is O minus, another is double bond O. Okay, now after that, if you do this hydrolysis, then this hydrolysis will give H plus, and this will attack to here, and now what we will get, that we will form that carboxylic acid. Okay, so whenever if you have that Grignard reagents and we are giving to this carbon dioxide followed by hydrolysis, then we are getting that carboxylic acid. Okay, so this is the one way of method to synthesize the carbolic acid from Grignard reagent if we have that carbon dioxide, because this is a highly polar and it will make the negative charge, and it will react with and it will form a carboxylic acid. Similarly, if you have that reactions of Grignard reagents with epoxide. Okay, so the Grignard reagent also react with epoxide to form that CC bonds. How it is? Let's say if you have that epoxide, like this is a epoxide we have, let's say, and here we have that Grignard reagent, let's say CS3 MgBr is there. Then what will happen, that note that this Grignard reagent, this is the minus and this is the positive, and this will attack to that side of the Grignard reagents where this is the less hindered. Here you see that here how many, one hydrogen is here, so this is that more hindered, means one methyl group is there, but in this case two hydrogen is there, means here it is the less hindered. So Grignard reagents will attack to less hindered side of epoxides. It means that it will attack to these groups, not to this group. Okay, this will attack to this group. Okay, so now what will happen, that it will attack to here, then after attacking that it will release here. So this is going to be that let's say name it 1, 2 and 3. Okay, so it will attack to that one groups. So this is 1, here we have that CS3, let's say, and here this 1, and here this is 1, 2 and this is 3, and okay, and 2, what we have, that here we have that oxygen, and here we have that negative charge. So whenever if you get any confused, then just numbering it, that make you that easier to do that reactions. Okay, so now if you do that hydrolysis, followed by, if you do that hydrolysis, then what will happen, that this hydrolysis will give that H plus, and this will attack to this, and it will get that OH. Okay, this, so this is the final answers. Okay, if that epoxide is given, then we will get this type of product. So note that whenever epoxide is given, then Grignard reagent will attack to that less hindered sites, and it will form that CC bond. Here we see that it will attack to here, and it will form that CC bond, and that OC bond has break, and it will form that after hydrolysis. Here we will get that OH bonds. Okay, so here what is actually that what says that why this reaction is happening, that CC bond is more stable than that OC bond, so that's why that OC bond has break and CC bond has fall. Okay, so this is that region this reactions which happen. So these are the main things about of that Grignard reagent, where it will do the reactions. It react with that, if epoxide is present, and it react with the carbon dioxide, it reacts with the aldehydes, that carbonyl groups. Okay, so that I have discussed in the previous class. So I think this is enough to talk about of that Grignard reagent. Although much more reactions are there, that we will solve that whenever you are solving that previous year questions. Okay, so today up to this, we will discuss more other reagents in the next class. Thank you.